Hello everyone, good evening. So hope please invite your friends and the colleagues so that we can start. Okay. So today we will take a very important topic in machine learning, that is model validation techniques. So in this we will see that what are the techniques that we are going to use for the model validation. And for these things we will see these three techniques: train and test sets, how we are going to divide our data set into training and test data sets. And we will see the K-fold validation technique. And one variant of this K-fold validation technique is leave one out cross validation. So we will see these validation techniques, and we will also see about how to do hyperparameter tuning. And we will try to implement whatever we will like train and test how to do this, and how to do K-fold cross validation, leave one out cross validation. So all the things we have to implement. And side by side, we have to see some basics, that what does this mean. And along with these validation techniques, we'll try to understand the model accuracy, how to find that what is the model accuracy. So we'll try to understand about the regression and classification. So how regression model and how classification models are evaluated. So these things we will see along with the hyperparameter tuning, and we will implement different types of the supervised for the classification and regression models. And we'll see that how to save model, and for the purpose of when we are going to implement when we are going to create an application. So in the last two sessions, we will try to implement fully with front end and back end the model, how to implement and how to look these things. So let's start model validation technique. So basically, what we have done up to just recap those things. So for the model building, so from starting we have seen how to build ML models. So in that we have seen supervised model, how to create supervised model, how to build supervised learning models. So in that supervised we have seen basically two different types of the models, that is regression. And today also we'll see how to validate regression model, how to evaluate regression. And with that we have seen classification. So in classification we have seen two different classification models, that are K nearest neighbor classification, KNN you can say, and other is decision tree. So we have implemented. Now we have to see that how you are going to evaluate and how you are going to validate these models. And in the regression model, we have seen simple linear regression. So we will try to evaluate the models with uh, different metrics. So these things, and also we have seen the unsupervised learning. So in unsupervised learning, we have seen clustering. So we'll see all these things, that how to validate models. And beyond the creating model, building the models, we have seen that what are different uh, pre-processing techniques that you have to apply before building the models. So data pre-processing we have seen. In that we have done many things. Okay, so we are not going to do again. When we will build full-fledged our application, so we'll try to do all these things. Like first we will try to do data pre-processing, and then we will move to the model building. So after creating the model, after building the model, whether it is supervised or unsupervised, the thing that you have to evaluate the model evaluation. Let's say this will be the third part that we are going to learn today. And the model validation. So when we were developing the model like supervised and unsupervised classification or the regression or the clustering models, so we have seen that what is the accuracy, what is other metrics that model that you can use for the model evaluation. So evaluating model means that how much the model is accurate. So different types of the model uses different metrics. Okay, so we'll see also this. Some of the model evaluation metrics we have seen, like in classification. For the classification, we have seen accuracy. So this is very important, that how much, what is the accuracy of our classification model. For the regression, we have seen just when we were developing the regression model, simple linear regression model. So we have seen also that what is the R square. So these two, like accuracy for the classification and the regression for the R square score. So we will again visit and we'll see different what are the other different matrices to evaluate a classification model or a regression model. And we have to see what are the different validation techniques. So main important thing that we have to do, that you can see that okay, my accuracy, my model's accuracy is 90%. Okay, so this is the score is okay for the regression, let's say 88 point 0.88. Okay, so okay, we get that accuracy, but how we can say that this accuracy is valid or not? So we have to look into the validation. So we have to validate our model. So first thing that we will learn today, that how to validate. So one that is important technique is to split our data, split data set into training and test, training and test data sets. Other is cross validation. So these things to understand that one variant of the class cross validation is leave one out. Okay, so we'll see. These are the very important topics, and somehow these are the like confusing topics. But we have to understand it's very important when you are going to implement your model, when you are going to deploy your model in real time. So we have to validate our model, that whether the model is valid, means whatever you get, you are getting the accuracy, that is real or not, that is actually getting on the real data set or not. So we have to do all these things. So let's first understand that what is, how you are going to do, or when you are going to one thing, why we are going to split our data set into training and test sub data sets, and what is the need and why we have to do these things. Okay, so that suppose let's move to the our uh, this. So we see that one thing is that one way that you have data set, you have complete data set. Let's say you have thousand data points. You have new data set. You have 1,000 data points, and let's say you are doing a classification model. Okay, so let's say that multiple features are there, input features are there, and you have these labels are the classes are the target values. Okay, so we say that labels are the class and the input features. Okay, so one way is that you are going to train your train model on complete data set. Other thing is that train model on a subset of data set. So that subset will be called as training set, and whatever the left out, that will be we will use for the test set. You are going to set test set. Okay, so let's say that you have 1,000 data points, 1,000 samples, are the examples you say, are the samples you are going to say are the data points. Okay, so let's say it data points. So 1,000 data points you have, and one way that you are training on the all data set. So what will be that your model, whether it is classification model or the regression model, your model will learn, not basically learn, your model will memorize. Your model will memorize all data points. So when we say that memorize data points, this means the model is learning by memorization. Means it's actually not learning the patterns. It's not learning the rules that we generally need. The model should learn a pattern. On the basis of the pattern, that model must be generalized on the new data points. So in this way, you will get, if you are training all on all the data sets, so you will get training accuracy, while the training will get 100% accuracy. That is not the required. Okay. But what we need our data set. We are going to train. Let's say this is our complete data set, that is 1,000 data points. So we are going to divide our data set into train set, training set, and test set. Okay, let's say generally 33% for the training set, and not 33, 67, and please like 2 by 3 and 1 by 3. Generally, what is the rule? It's not the hard and fast rule. You can take 30%, 30% for the test, and rest 70% for the training. You can take 20% data for the test and rest 80% for the training. Okay. So this way we are going to train our data set on this. Our model will be trained on this only 67%, means 670 data points will be used for the training, and rest 330 data points if we have 1,000 data points. Okay. So these data points will be used for the test. So this way, what will be, when you are training your model on complete or whole data set, so it will memorize all the data points. Okay, but when you are going to predict or the classify for the new data point, it will not give the accurate result. Okay, not it will not give the good result. But when we are going to we are going to divide into subsets, two subsets, one for the training and one for the test. So what will be, we are going to train on the some part of the data set, and we are going to test on other part of the data set. So while testing, you will see that whether your accuracy is good or not. So if while testing accuracy is good, so this means for this testing data set, while the training, this test data set is not used. So if the test accuracy or test score, let's say score So test score is good. Let's say like 87% or 0.87. Okay, let's say score 0.87. So if your score is there, let's say in point, if percentage you are taking, so 80 multiply by 100, 87%. So if test score is this, then we can say, okay, while the our model trained on the different data set, and now we are testing on different data set, okay, that is not seen by the model, but still it's giving the good result. So this is the best way, not the best, but there are different other ways. One of the best way that you have to divide data set into different, like one set training and test. So these things are there. And if you are going to train your model on all the data sets, so that it will memorize the all data points, that is a problem of overfitting. So when your model is overfitting, so what will be the problem? So model accuracy while the training, at the training time, model accuracy will be good, model score will be good, but when you are going to predict, when you are going to find that uh, on the unseen data, new data, so it will not give the good result. So we have to avoid the overfitting. So that's the one thing that we can use. That is, we are going to train on some part of the data set, and we are going to use the rest of the that thing for the test. So these are the things that we can. These are like using 33% or the 67% for the training. It's not 100% hard and fast rule. You can decide, you can choose, and we'll see that how we are going to choose that what will be the training percentage and what will be the testing percentage. How can you decide? Okay. So one of the, we will see, just we are going to implement, we will implement, and we will see that is there any drawback of the test, train test split approach or not. When we are going to split our data set into training and test. So is this best way, or it has also some drawbacks or some limitations so that we can go for the new, uh, a new way, new techniques. So let's move to our Jupyter notebook. Basically, what we are going to use, we are going to use today collab. You can use Jupyter notebook. And before that, I have uploaded the files, whatever the files we need for the today. So go, I'm sharing the link for this GitHub repository, and in the chat. So side by side, you try to do all the things that whatever we are doing here. So first, you download this model validation and selection. I have uploaded here as a GitHub repository that this is ML part. It's not the sixth part of this program. It's ML, the sixth day of the ML program. So I have written here. Okay. So in that you will get a one.ipynb file, that is our Jupyter notebook file that we will be using. And for that we are using two data sets. So you can check here that what is this that we have implemented for all the things, how you are going to implement train and test, and how you are going to use validation and all these things. Okay. So one by one we are going to do all these things. Hyperparameter we also check. Everything we'll see. And along with this, you have to download this also, newspaper data. We have already worked on these things. We have used the newspaper data when we were working on the linear regression. Okay. So again, we will do linear regression. and we'll try to find out the score of the model, and we'll try to implement the model. Okay, validate what will be the validation. And in the next sessions, we will try to implement with full uh, front end and back ends. So, so you have to download these files. Go one by one. You can download from here. You can download. Okay, and these three files you download. And if you are working on the Jupyter notebook, so you can just go and open any command prompt like terminal using command prompt or PowerShell. Or if you're using Mac, then you use your terminal. Okay. So in that, what you will do, just you have to write Jupyter and notebook. So your Jupyter notebook, an interface like this will be open. That is 888/3. And wherever you have downloaded, so open that file. So I have downloaded, let's say I have downloaded here. Okay, so you will get all these things. You can open this IPYNB file and it will be open. You have to place your data sets, your data set, these newspaper.csv and prima indians dapties data.csv into the same same directory. You have to change this one because I had worked in the Google Colab, so I have given the respective path. Okay, so you have to give your respective path. If you are having your data set in the current directory, working directory where you have this model validation methods notebook. Okay, so it's just go for this, it will be open. If you have a data set in different directory, so you have to give the relevant path, okay, respective path. We will understand all the things one by one. Okay, so what we have to do, let's open our Colab. So what you can do, just go and you can search on the Google Colab. Okay, why I'm repeating daily, because this will not take too much time, and if anyone is new, so he or she can understand that how you are going to upload, because while uploading it's how to upload Jupyter notebook on your Google Colab. Okay, so that's sometime it's confusing for students. So what you have to do, let's say let's start beginning. Okay, just go to file and you will get here upload notebook. So this is upload notebook, and you go to browse, and then you will wherever you have your data, the IPYNB file. Okay, so let's go not in the 5, but where I have an 6. Okay, so wherever you have, you will get the this wherever you have downloaded. So you go and select this and open. So it will be uploaded, and now for this thing you have to what you have to do, you have to, okay, so what you have to do, you have to upload your data sets also. Okay, so here you can upload your data set and sample data. You can find some pre-uploaded data set by Google here, like California housing train. Okay, so train and test they have given in different uh, file as a different file. Okay. So you can use these if you are working on the house price prediction and something like that. So what we have to do, we have to upload these two files, newspaper data and the Prima Indians Diabetes data. These two are the CSV files. So both you can upload directly. Either you go and one by one you can upload. Okay. So wherever what the dataset name that we need, Prima Indian. So I have to change. I have to give the respective path. It that I have changed here. So because of that, so you have to give the respective path, you can go where this is the data set. So you can find copy path. Okay, just to copy path and just paste here. Okay, now this is your complete path. The current working directory is basically slash content. Okay, so whatever the data set we are, wherever we are working, uh, working directory is basically content. Okay, so we have to put all the data sets and the files within the content. So here sample data is there, and within sample data our data series is there. So let's understand from the beginning. Let's move to the our slide. What it says? It says that you have to split your data set into two parts. So one part will be your training, and other part will be your test. Okay. So what can we do for this thing? You can go for the that what we need basically. This is the sklearn library, and we have a model selection module. Okay, so you can go and search for the model selection in the sklearn. So this is basically model selection, and it provides different types of the model selection technique. That what are the techniques? Basically, model validation technique is what we are going to select, how you are going to select your model. So that that will depend on the strategy. So there are different ways like k-fold. We will understand what is k-fold. The next is we are going to understand k-fold. Leave one out, we will take. These are the different way. So we have to move, and we have to check that this model selection is providing a function that is train test split. Okay. So you can go and you can search where is train test. Is there? Yeah. So you can find train test split. This is a function that is provided by. So it will take array type data. Okay. So it will take array type data, whatever the numpy array, and in pandas you have data frames. Okay. So these things are there. So what it will take your the data points data set, that will be x and y. We'll see how you are going to take x and y, and here you have to decide that what will be the test size. So test size is basically what, if you are going to give 33%, so you have to put here 0.33. Okay, so that will be, if you are going to, if you want to take like 30%, so you can put 0.3. Okay, so this will be your for the testing, what will be the testing size. So from starting, we are doing this like pandas. We are taking pandas for the to read our data set as pandas frame. So from sklearn, we have imported here from the model selection. Okay, so sklearn from the model, we are importing train test split. So this function will split the data set into two subsets. One train, another is test. And we are going to use logistic regression. Okay, so basically this is logistic regression, and this is not used as for the regression but used for the classification. Okay, so we haven't gone through the logistic regression, so that's why I have taken logistic regression as a new model. Okay, so what it will do, you have to, it will classify. So you can check basically what is logistic regression, and for detail you can go for again sklearn. Okay, so sklearn is very important library, and for the machine learning models, and for the data pre-processing, and for the model validation, for the saving model. Okay, how to save model and how to use the saved model. Okay, all these things when we are working on the machine learning model. Okay, So this is very important library. So I recommend that you go whenever you are using any library, any model, you're taking any supervised and supervised model. So go for the skill learn and check that what does this algorithm or the model is. Okay, so what different parameters are there, what different attributes it's taking, and what returning. Okay, all these things you can go. So so what today is we the our main goal is to validate model. Okay, model validation. So first what we will do for the model validation, we will try to build our model. We'll build for the validation. To validate, we need our model. Okay, so first we build model. Okay, so we will build our model. So we are going to take our logistic regression. Name is regression, but used for classification. Okay, in machine learning, when we are talking about machine learning, so in machine learning, this logistic regression is used as for the classification. But there are different application as a regression also when we are going for the some statistical modeling. Okay, so some in the statistics or in statistical modeling, there are different application in the regression also. Okay, so it's not that only used for the classification; it's also used for the regression. But in machine learning, mostly we are using for the classification. So we'll see on our data set that how it will work. Okay. So we are taking diabetes data set. So you can check that how our diabetes, this Indian prima diabetes data set looks. So we already have gone through these. Okay. So these are the data points, and the last this one, this column is basically our class. Whether one represent diabetic means positive. Okay, positive, whether it is diabetic or not. Okay, positive and negative. Okay. You can say that this may be not diabetic and this will be diabetic. So we have only two classes. So binary classification is there. So if by for the this logistic regression is used for the binary classification. Binary classification means what? If we have only two classes, we have only two labels, so that will be binary classification. So in binary classification, you can use logistic regression. If multiple classes are there, like three classes, four classes, and more than those, so you can't use logistic regression. Logistic regression will work only for the binary classification. So we will see that there are only two classes, 0 and 1. And so we just implement the logistic regression, and we will try to find out while implementing how to uh, yes, how to divide our data set, split our data set into. So this logistic regression is there. So all the things that we have already done, these things you read file. Okay, and you give column name. This is basically what column name that you can see data set. Data set doesn't have the column names. Okay, so here it doesn't have column names. So you can give your column names. You can go and search for the Prima India diabetes data set, the class names. Okay, the column names. So these are the column names basically, and you are going to create our data frame from the data set CSV file. We are going to read our CSV file, and that will be our data frame. Okay, so now we are taking values only. We are taking values only. So you can run this, and let's check that what is the data frame and what is values. Okay, so you can go here. So you can check how data frame looks and how array looks. Okay, so your data frame will looks like this. Okay, so these are the column names that we have given, and it will have 7, 6, 8 rows and these things. Okay, and side by side you can check that what is array. Okay, so when we are going to take a train test split, so we have seen here that it should take an array. Okay, so it should take array or arrays. Okay, so that's why we are converting this data frame into array. So what will be the array? Basically, you check, you can go and check array, just whatever. So this will be, basically this is numpy array. Okay, so this will be array and two-dimensional array, like table. You are going to see that the first row is this first row, then second row, third row, fourth row, and 7, 6, 8 row. So this way you can go, and this is the important thing that we are trying to understand. So let's go like this. Okay, let's go one by one and try to understand. Then it will be easy for us. So we have array that we have seen. X is basically what? X is from here to here that we have seen in previous classes. Okay, so from this 0, 1, 2, 3, 4, 5, 6, and 7. So 0 to 8 in the index, it will give you 0 to 7 in actuality. Okay, and the eighth is our basically class. Okay, so for y we are taking this eighth only, and for the x we are taking from 0 to 7. We are giving that we want 33% for the test data set. Okay, and rest 67 for the training data. So we give what is test size, that is 0.33. What is x? We have seen this is array. What is y? We have seen. Okay, so you can check what is x and what is y. If okay, you can check also x and y, basically how the x and y looks. So you can go and just check that. What is this? X is basically, it will take only 7 uh, columns, and y will give that y should be capital Y here. So this will be 1, 2, 3, 4, 5, 6, 7, 8. The like from up to how many we have? 7, 6, 8. So it will have 7, 6, 8 entries, but the unique values will be 0 and 1 only. Okay, so you can check use shape also. Okay, what will be the shape of this Y? So it has 7, 6, 8 entries, and basically it is only 1D array. Okay, and your X is basically 2D array. So this way, this will be your the classes 0, 1, 0, 1, 1, 0, and X will be your these 7 from here to here up to A is 7 columns, and it will be like all these 7, 6, 8 rows. Okay, so we reach here that we give X and we give Y for the class and the input features and 33%. And now what you will do, this function will give you 4 things. Okay, one will give you for the um, x part, that from this x part. So whole this thing, just give me 1 minute. Where is it? So yes, so Yes, this array and x we have taken here somewhere. Okay, so x you just take. We can check that what is the x train and x test. Okay, so x train and x test basically what it will take. It will give you x train means the data set is divided whole data set. This you can check this whole data set, and train will have only up to this part, and let's say 33% data points. So from here to here, or from all the data points, 33% data points will be assigned to test data set. Okay, so out of this 76 uh, out of 768, 33% will be assigned to the test, and rest it will be assigned to the training. Okay, so we will check that how it will work. So here you will say, and for the training, likewise x train for the all the inputs, x test for the all the input features, 6 input features, 7 input features, and the values for the test, and this y train, y means for the classes. So classes for the labels for the training train data set. This y test will give you labels for the test data sets. So it will give four things, four sub parts. X train, that is our training data set, that has only input features for the training. X test, only input features and values for the test. X Y train, that will be your classes or the labels for the training data set, and Y test will give you the labels for the Y for the test data set. Okay, so these things you can work, and when this will be there, now you are going to create our model. So that is, we have taken our model as from the linear model we have imported logistic regression, and here we are giving max iteration, how many times it will update, it will iterate, like it will take first, it will train first, and then after training it will find the output, like predicted output, and what was the training inputs, training labels what was, and what was the predicted output, predicted labels classes. It will take the errors, it will find the errors, and it will compute the loss function, then it will try to minimize the loss function. Okay, then it will update the parameters. Then on the next iteration again, it will train the model, and it will find the predicted output, and these things will going again and again up to 300 times. Okay, so 300 iterations for the model training it will take. And here we are giving for the training X train and Y train. So this X train basically input feature, and this Y train is what? Y for the training means labels for the training, or the classes for the training we are taking. And this will give you the score. So just run one time and you can check all these things. Okay. This X train and Y train, how these things are, how you can find what will be the X train. Okay. So let's say that what is X train here. Okay, so it's not giving good, but you can find the shape. Okay, so and before that, let's do X dot shape. Okay, so you can understand. So if you go for the X dot shapes, you will get that whole data set for the X training is what, for the whole data set for the input feature is basically 768 entries are the samples, but for the training it is reserved for the 514 that is 67% of this. Okay, and likewise you can check also for the y dot shape, you can check Okay. So it will give you y dot shape, that is basically the 7, 6, and y train basically. So you are going to check y train shape. Okay. So you will get uh, uh, 514 samples are reserved for the training, and 514 classes or the labels are also reserved. So how many training samples are there? That many test classes, not test, but output classes are the labels will be there, respective. So respective way. So you can check these y only, y underscore train, that what are. So these are 0101 up to the 514 entries are there. Okay. So this way we can split our this data set into different subgroups, training and testing, and we can train our data set on the train subset, and we can test. See here, while training, while we are fitting our data set, our model, so we are taking X train and Y train. While we are going to evaluate, this is model dot score is basically it give you the score of the accuracy. Okay, accuracy, how accurate our model is. So this for that thing we are going to use test. Okay, X test and Y test. So for result, you can directly go and you can find what is the result. Okay. So how, okay. So you'll result find it is basically the model dot score function will give you a score in between 0 and 1. Okay. So if 0 is there, so 0% accuracy, 1 is there, 100% accuracy will be there. And in between, whatever the point is there, so you have to multiply to get the percentage accuracy. So 0.78 will be your basically 78 point this 74%. Okay. So this way you can go for the training. You can find the score of the test also. Test score also. So you can check for the model dot score, and you can give X train basically. You can check for the training accuracy. There are two types of the accuracies. While training, how much accuracy is there, how much accurate our model is being trained, and while testing, what is the accuracy. So you can check for the, so you'll get 77%. Okay. So training accuracy is 77% and test accuracy is basically 78%. So when our model shows like test accuracy and training accuracy about similar, like about same. Okay, it's only 1% is difference is there. Okay, so mostly training accuracy and test accuracy, while training and test accuracies um, are about same. Okay, both are same. So you can say the model is generalized. Okay, when training accuracy is very high, like 90%, 98%, and something like that, and your test accuracy is low, like 70%, 65%. So you can say your model is overfitting. Okay, so your model has a problem of memorizing the data points while training. But while testing, when on testing on unseen data, it is not being generalized. Okay. So when we say that models should be generalized, means models should give uh, good accuracy on unseen data points. Okay, that is not used. Unseen data points means unseen data points are not used in the training. Okay, so here you can see the test data points are not used while training. Okay, only 67% data points are used for the training, and these points are not used. Okay, so I hope this will give you some insights about the training and test. Now let's move to the evaluate how we are going to use cross validation. Okay, So the next point while we are working is basically cross validation. Okay. So what will be the cross validation? So in cross validation, basically what we were doing in training and tests. Let's say in train test split, what we were doing splitting our data points into two subgroups only. Let's say this 67% was the train set, and this 33% was for the test set. Okay. But now in the cross validation, what we will do? Cross validation, we will divide our data set into uh, folds, into number of folds. Let's say 5 folds. If you want to divide your data points into 5 folds, so what will be your whole data set will be divided into 5 folds. Okay, let's say like this. Okay, so when you are dividing 100 samples into 5 folds, so what will be 20% data will be in each. 20% data points will be in each fold. So here 20%. So this will be, let's say, fold 1, fold 2, fold 3, fold 4. Let's write like this: fold 1, fold 2, fold 3, fold 4, fold 5. Okay. So all this will be having 20% data. Okay. Now what we will do? We will use one fold for test, and rest for the train. Okay. In first go, and in second go, what we will do? We will use the second fold. This for the training. Okay, we have an very good example for this in our PPT. So look this one. You can check this one. So we'll see here. So we have divided our whole data set into, let's say, 5 folds. Okay, all 5 folds will hold the same percentage of data points. Okay, so like it will have 20 data point, it will have 20 data points. If we have 100 data points in our data sets, so it will be 20 20 20 in all folds. Okay, if some mismatch is there, so last fold will have maybe less than 20. Okay, let's say if 98 data points are there, so the last one will have only 18 data points. Like way we have to, so this one fold we have decided for the test. Okay, and rest of the you can see here the green one is for the testing training, and the this yellow or the orange is for the testing data set. So one fold we will use for the testing, that will be uh, that model is trained. Okay, our model is trained on these four data, the folds, and one fold. Our model evaluation will be on this fold. Next, model 1 you will get. Now you will get a model 2 when you are going to train. Okay, so now we are going to use second fold for the training, for the test, and rest other for the training. Now with this for this one model, fold 3 will be used for the training. So this way, not for that. So model 1, model 2, model 4, model 5 will be for training, and fold 3 will be uh, for the testing. Okay. So okay, for the confusion, this is fold 1 basically. So fold 1 and fold 2, fold 4, fold 5 will be used for the training, and fold 3 will be used for the training. So when you are training on this, on these folds and testing on the fold 3. So you will get a different model. Okay, different model and different accuracy and different parameters. All the things will be different. Now what you will do? Now this fold 4 will be used for the training, and rest of the other 4 folds will be used for the again I mistake. Okay, so fold 1, fold 2, fold 3, and fold 5 will be used for the training, and this fold, that is fold 4, will be used for the test. So this way you will get the again another the model. And now here fold 5 is used for the testing, and from 1 to 4 will be used for the. So as many folds will be there, that many you will get the models. Okay, model accuracies. So for what you have to do, you will get different accuracies. Let's say here accuracy or the score. Here score you will get score 1, you will get score 2, score 3, score 4, you will get score 5, you will get for this. Okay, so different scores you will get. So if you are doing for the accuracy, so what you will do, take the mean accuracy. Okay, mean accuracy. So mean accuracy. So for that, mean accuracy will give you the like inside that this is the accuracy. Okay. So it may be some case like that when this fold is there. Okay. In the first split, like 5 fold we have split it, you get here 78% accuracy. In some like third one, you get 90% accuracy. Okay. Here you get 7% accuracy. You will get 85% of accuracy. You will get 80% of accuracy. Okay. So this way you have to uh, take the mean of all accuracies, and then you have to say that okay, this is my accuracy. This is the accuracy of the model. Okay. On the basis of this fold, you can't say only that this is the model accuracy. Okay. So we have to go like this, and we have to check. We will see that what we can do. So for this thing, so for this k-fold approach, this is basically k-fold cross validation technique, and this is very good technique when we are going to validate our model. Okay, so when we get the accuracy, when we trained our model, and when we have find the accuracy. Okay, so now we have to find that whether this accuracy is valid or not. Okay, so for the validation, so basically what we will do, let's move to our the same, all the things we have same. Okay, we have our data set same, and again I'm saying that if anyone who has joined new, recently, so he or she has to download these things, newspaper data and the Prima Indian, Prima Indian diabetes dataset, and this will model validation method will give you a notebook. Okay, so better to download and work side by side. So we have all the things. We have data set. We have these things we have read that in earlier that we have done these things. Then we have converted into array. Then we take an X part and Y part. X is what? The input features, and Y is what? The class. Okay. So we have seen, and again I'm saying here from here to here, you can see here to here. This is all these things. Okay, this is our data set. So from A to H, this is from the 1, 2, 3, 4, 5, 6, 7, 8. Okay, these A, okay, 8 are now, okay. These are the your input features, and the last one is basically what? Last one will be your the classes. Okay, so from A to H, the value it will be stored in capital X. Okay, and this part 1010 is stored in Y part. Okay, so X will include all 8 from 0 to 7 columns, and Y will take only the last column. Okay, so don't confuse this. This is your class, the last one. And it says that how many folds you need. So we have decided here that we are going to take 10 folds. Okay. So if you're taking 10 folds, then we have seen in PVD that you will get 10 accuracies, 10 scores. Okay. Now you have to find out the mean of those 10 scores. And then what we have to do is k fold you have to import from the model selection. Okay, so we have taken here model selection, and in the model selections we have seen that k fold is there. So you can go for the sklearn.model selection. So you will find here k fold. So in K fold, you can see that how many folds. If you are not giving number of these splits, so it will take by default 5. Okay, shuffle is false, means you are not going to shuffle your data points. Okay, random state is not is none. So what we have to do, we have to give this one number of these splits according to our data set. Okay, that how many splits we can have. Okay, let's say if you have only 100, if you have only 100 data points, so giving 5 splits is fine. Okay, if you have thousands, 2,000, more than that, so you can give like 10 splits or something like that. So that you have to decide the number of the splits, so that in each split you have sufficient data points. Okay, so in each splits you have sufficient data points. So while training on while testing on one split, one fold, you can have sufficient numbers of the data points for the training, for the testing. So that you have to import k-fold from the sklearn dot model selection. Okay, so that is one thing, that k-fold you need to find the folds, how many folds you are going to do. Okay, and then that cross val score. This is basically cross validation score is there. So this function is very important, cross validation score, so that you can search for the cross validation score sklearn. Here you can go. I recommend always go for the official website and you can find out these things. So estimator is basically what? This is basically your model. Whatever you have trained model. You have taken, like here we are taking the logistic regression. Okay, so this logistic regression, here you are going to take model is basically logistic regression. You are giving maximum iteration 300, 400, how many times you want to train your data set, your model on data set again and again. Okay, so number of iteration you can give. And if you are not giving number of iterations, so it like 100, I think 100 is 100 iterations is default. You can give more number of the iterations, so that your training is proper. Training, you train the model properly. So this model is basically your estimator. Okay, so for that estimator, now you have to provide the X and Y. Okay, so if you are having supervised machine learning model, so you provide X and Y both. You have unsupervised, then you provide only X part. Okay, so Y is optional. If you have your model, if you are working on a supervised machine learning model like regression classification, so you can provide X and Y both. And other thing that you can choose. Okay, cross validation you can have, yeah, all those things. Okay, so we are providing. We have taken k-fold, number of splits, how much number of splits, how many number of splits there. Shuffle you can make true or false. Okay, so if shuffle is true, then your data set may be shuffled. Okay, and these things are there for here. And You can go for the CV, cross validation. Cross validation will give you how many folds you have decided to split, and it will give you the data set, splitted data set. Okay. So you decided K fold, then model you are given, then you are going to find out the result. Okay. So you run this and you can check one by one all the things that what is K fold and what is other things. Okay. So if you go for the K fold to check that what the K folds look, so you can find here the K fold is basically split and it will give you these parameters. K fold will take this is a variable or that holds this. Basically, it's object. Okay, this is an object. We can check here. This is a class. This is a class. So K fold, this K in capital, F in capital is a class, and you can create an object of that class. Okay, so this K fold is small K fold is basically an object that holds these features. Okay, now model, you train the model. Now you can get the result. Okay, so what it will give? It basically it has this score, class validation score. When you are going to take 10 splits, okay, 10 folds, you have decided for the 10 folds, it will split your data set into 10 folds. It will train on the 9 folds and 1 folds for the test it will have, and it will test on the one fold, and this way it will take the respective the one fold for the testing and all other nine folds for the test. Okay, so this way you will get 10 accuracies, 10 models, and you have to find out that the mean of those. Okay, so you can check that what results is basically what results give. So here you can see here the first split that it has like 10 folds, 9 fold for the training and 1 fold for the testing. So you can check here that this is basically what this is first accuracy, first score. Basically, this will give you a score, first score for the classification. That will be your accuracy basically. Second, third, fourth, fifth, sixth, and up to 10. You will have 10 accuracies. So you have to find out these 10 accuracies will be for the all splitted. Okay, so like 10 folds are there. So 10 you will get, you can visit this one like here. We have 5 folds. Okay, so you have 5 folds. So you have 5 different combination of the folds. Okay, 5 combinations. So 5 models will be given and 5 accuracies you will get. Okay, so now here 10 splits are there, 10 folds are there. So you'll get 10 accuracies here. So just get the mean, get the standard deviation and something like that. Okay. The next is that let's move that one leave one out cross validation. So this is a variant of this one, that cross validation, k-fold cross validation. So in that, what we are doing nothing but we are taking, let's say 100 of the 100 data points we have in our data set. Okay, so 100 data points you'll have. So you split in 100 fold your data set. Your data set will be splitted into 100 folds. How many data points? 1000 data points are there. So it will be splitted into 1000 folds. And 99 out of this 99 folds will be used for the training, and only one fold for the test. So see, every time where if you have 1000 data points, so 999 data points will be used for the training, and only one data point will be used for the test. Okay, So this is why this is the name, like one leave one out. So this is called leave one out. So means we are leaving only one data point from the data set, and you are training rest of the data sets. Okay. So this way, if you are doing like this, so this is basically a variant of the data, this k-fold validation, where you are dividing your data set into the number of the data points. Okay, so as many data points will be there, so as many folds you are giving. So let's just check that how you can do this one. So this one will be done using all the things that we are doing. So you can find leave one out. So leave one out. This function will give you basically that only one data point will be left out. Another rest of 99 will be used for the training. Okay. So logistic regression we are taking, model you have taken, and cross validation you are taking this. Okay, leave one out function, and rest of other things that frame X and Y, all these things we are taking same. So just give me 1 minute. So what we will do? Uh, so for the cross validation, so you have seen here cross validation is go to find. You have to provide which type of the cross validation technique you are going to use, whether k-fold you are using, so how many k-folds will be there, whether you are using the that one, leave one out. Okay, so you have to apply cross validation technique here, and the rest of other things are same, like X and Y you are providing, and you are providing model. Model is, this is the estimator. You can find here this the estimator. Estimator is exactly the model, whatever the model you are taking. If linear regression is there, logistic regression, decision tree is there, whatever the model is there. So this is your model. Okay, basically. So let's run this one, and you can find out the result. Okay. So in that we have, see, it will take a lot of time. Means in comparison to other k-fold cross validation. So in k-fold you are dividing into if say it's 10. Earlier we have taken here 10. Okay, so it will give you 10 accuracies. Here whatever the size of our data set is 768. 768 data points are there. Okay, so it will give you 768 accuracies. Let's check that the result. What results give us? This result is, okay, where it is result. This is cross validation. Okay, so this is basically giving us the not score, not the accuracy, but it's giving the labels. Okay, what will be the labels for the X and Y. So here we are taking X and Y complete data set. Now we haven't divided into training and test. Okay. So here we are taking X and Y without dividing into training and test. We are taking these things, and we are splitting our data points into the number of these things. So you can find, okay, okay. Basically, it's accuracy. How is accuracy? Because see, for the test data set, for the test, not test, for the test fold, if you have 100 data points, you have 100 data points. Okay, so 99 are used for the training, and only one used for the test. Uh, test. Okay. So if only one data point is there, so whether it will be correctly classified or incorrectly classified. So the accuracy will be either 1 or accuracy will be 0. If it is correctly classified, then it will be 1, like it will be 100% accuracy. If it is incorrectly classified, because only one data point is there, so only two options are there, whether it is correctly classified are incorrectly classified. Okay, so it will be 0%, either one is there 100%. If correctly classified, so 1%, and incorrectly classified, so 100%. Okay, so this way you will get number of as many uh, as many data points are there. So as many these results you will get, these scores you will get. You can find a result dot shape, results dot shape. Okay. So see 768. So these results contains 768 points, 768 accuracies. Now just you take the mean and you will get the your accuracy. Okay, how many are the correctly classified? So it's 77.6, means 77% uh, the data points are correctly classified and the rest. Okay, you can go with the standard deviation also and these things. So the next is model evaluation. Yes, attendance will be provided on time. Okay, it's maybe like just 5-10 minutes. You'll get the attendance sheet. Okay, nice. And so we are going to take the next one, that is basically what are the different accuracies to find the to basically evaluate the model. Okay, so how you are going to evaluate. So just to go, these are the things that we will check, that what are the accuracies here. Okay. So basically we are taking for the regression model. So two things, one for the regression and one other for the classification. Okay. So different accuracies are there. So we have already seen when we were working the linear regression model. Okay. A simple linear regression model. Okay. So basically this was that you can find the model dot score and you will give x and y. Okay, x part and y part. So this is I have taken for the newspaper data, because that we have to implement regression. So we have to take the another type of the data set. So if you run, you will find. So this model dot score. So any model, if you are using whatever the model you are using, okay, so linear regression you are using. So every model has dot score, linear regression. Okay. So every model will have a score function. Okay. So you can see here, this score function will give you the respective score. So for the linear regression, it will give you R square. Okay. So for the regression model, the R square or the coefficient of determination, this is the best way to find out the accuracy. Okay. So this is basically 91% accuracy is there. Okay. So this has some intuition that what is the meaning of this, but the time not permits to go into detail. And mean absolute error is there. So you can use this also, mean absolute error. Okay. So what are the difference between the uh, output labels, output values, basically target values, and the predicted values for the this. Okay, so you can find the difference. This will give you a difference, basically difference, and then you will take the respective difference and then sum and then take mean divided by the number of things. Okay, and mean squared error, same. You have to take the error, that is actual target value minus sub whatever the predicted value you are getting, you subtract, then square, and then you take mean. Okay. So this is why this is a square value. So that will be the max. It will give more value, and you will get root mean square. Whatever this you are taken, just take the root. It will give you the root mean square. And from the metric again, you can take R2 underscore score. So it will give you exactly whatever the model score you have, model dot score. Okay. So this way you can find, okay, this is an example of Rees regression. Okay. So you can use Rees regression also. You can find out what is 91.8 and it gives 91.8. So basically both are giving same. So Rees regression or the simple linear regression you will see. So these are the, and for the classification, what are the different for the classification, what are different uh, evaluation, model evaluation metrics. Okay, so you will get basically a model evaluation metrics. So there are some like accuracy is the one that are commonly used. So accuracy is means total data points. Okay, how many data points are there? Total data points, and that is truly classified. Okay, so let's say that will be there are how many 100 data points are there, and out of 100 data points your model is able to classify 70 data points correctly. Correctly classified 70 data points. So 70 over 100. Okay, whatever the all data points are there, 100 data points, and only 70 data points are correctly classified by your model. So this will be your accuracy. Okay. Another is the confusion matrix. Okay, so we can go and you can find here the confusion matrix is basically very important topic here. This is one. Okay. So actual value or predicted value you will get. So wherever you are going to put actual value or predicted value, so just check for that. Okay. So actual value. So actually, this lady is pregnant. Okay. So now we have to check that. We have two data points here. One is male and one female, and this lady is actually pregnant. So now you are going to say that, okay, if actually pregnant and the predicted value is also pregnant. Yeah. So the actual value and predicted value both are same. Okay, both are true or both are same. So you can say here this is true positive. So this is true positive, and the flip side of this one, this is also actually he the person is not pregnant, and the predicted value is also okay. So negative part, negative is also true but negatively true. Okay, so that will be true negative, and false positive is that this is classified the predicted as pregnant, but actually it is not pregnant. Okay, this is false negative, this lady is pregnant but predicted as not pregnant. Okay, so this will give you whether you are going to find out how many data points your how many data points are there that are correctly classified as so as it is. So that will be a true positive. So if it is class one, so a particular data point, so a particular, so let's say zero class or one class. We have two classes. So if 130 data points are let's say with examples, so it will be good. Okay. So we will go to our here you say this is basically the actual and the predicted. Okay. So in that confusion matrix obtained by sklearn library, this rows will be actual, and these will be predicted. Okay. So actually 128 entries, 128 data points are predicted as they are actual. Okay, so this is true positive will be there, and this will be that here you will get actual and predicted as. Okay, so this is, let's say, the class 0, class 1. So class 0 and class 1. So okay, actually this was, and you can say 0 or 1, here 0 and 1. So you can say actually belongs to class 0 and actually predicted as class 0. Okay, so you can say 128 data points are there that are correctly classified. And this one, 48, 48 is basically belongs to class 1 and predicted as class 1. Okay, so you can say negative in opposite way, opposite that negative part of the 0. Okay, so it is not 0, but it is also correctly classified. Okay, so these two, true positive and true negative, are correctly classified. Okay, so these two things are good thing that it was not in the class 0 and also predicted as not in the class 0. Okay, so this is correctly classified, but that. So what we will get, uh, yeah, and these things you will get that false positive and false negative, false positive and false negative. Okay, it was not belonging to the class 0, but it is predicted as class 0, so that will be a false positive. Okay, false negative, it was not belonging to this class. Okay, 0 class, but it is predicted as this class, so this will be false negative. So this way we have to check and go the things. Okay, and so let's move that we have to cover one more topic. So we will not have too much time. Okay. So that if you go and run this, so whatever the things that you have to take, accuracy score, that will be exactly how many correctly classified divided by total number of the data points. So classification report will give you all the things. Okay, this will give you basically it will give you a confusion matrix, and okay, confusion matrix we are taking separately. So it will give you precision, record, and F1 score and support. Okay. And other things are there, confusion matrix we are taking. So from here to there, all the things are same. We are training, we are taking data points, we are splitting into training and test data set. Okay. Then we are taking random classifier. Okay, random forest classifier basically. Okay, you can choose. We have taken a decision tree classifier. We have developed decision tree classifier. You take random forest classifier. We have taken this one to give that we can take different types of the uh, classification methods, classification algorithms. Okay, model. So just predict, and now you are going to test your y test and y predicted. Okay, so this is actual class, and this is predicted class. So you can find the accuracy and confusion matrix basically, and you can find actual class and predicted class. So how many correctly classified you can check. So you can find here accuracy score, and this one in classification report you can check. Okay, so all these things will give you these things. So these things you can find. Uh, you can check that what these are. We have to explain the precision and the recall and F1 score and the support and these things. This is for the class 0 for the one class, and this is for the class 1. So you can find, you have two classes in that data set. In that data set we have two. two classes, zero class and one class, means whether it is diptic or not diptic. So you can check. So all the data points are related to uh, zero class. The number of the data points in zero class in test set is 146, and that belongs to class 1 in test data set, that is number of data points 87. Okay, so precision and recall, all these things you can check the formula, and you can find. Okay, so precision will be true positive and all the positive, whether false positive or the true positive. So whatever the predicted positive, so let's say number of the predicted positive is 80, but in that how many true is there? Let's say 70 only. Okay. So 70 over 80 will be your precision. Okay. And recall will be true positive and false negative. Okay. So you have to take true positive and false negative, and then out of those numbers you have to find out the true positive, how many true positives. Okay, and this F score will be the harmonic means. Okay, just you have to find out precision and recall, and then you have to multiply, and then to take two times and divide by the recall and precision. Okay, so this way you can calculate all these things, and these are the evaluation metrics, evaluation matrices basically for the classification. Okay, but you go for the accuracy, that the accuracy is the mostly used when we are working on. But these are precision, recall, and all these things. They have the the interpretations. What are the meaning of the precision? What the interpretation of the recall? When you are going to use the when you are going to focus on the recall on the basis of your uh, on the basis of the problem statement. Okay, which type of your data set you are using, what is the problem statements. Okay, so on the basis of these things you look all these precision, recall, reference score and other things, then you decide that whether your model is okay for the production or not. Okay, so other important other very most important thing topic is hyperparameter tuning. So it was basically the most important that I have to take in detail, but due to the time constraint, let's try to finish this within our time. Okay, so when we talk about the, let's have just a quick overview of hyperparameter. Okay, so you have heard about parameter, okay, and another is hyperparameter. So this is also used, also asked many times, that what are the difference between hyperparameters and parameters. Okay, so let's go for any of that we have taken. Okay, let's say what we are taking, KNN, K nearest neighbor classifier. Okay, so K neighbors classifier. So go for the KNN classifier scale learn. Then we will try to understand what are the parameters and what are these things. Okay. So see here, these number of the neighbors. What is the value of the neighbors? On the basis of you are going to decide that this data will belong to this category. Okay. So this number of the neighbors means the parameters, those values, the values, like if you are taking, let's say, simple linear regression, one thing you are taking. So in that, you decided that y hat is basically what? Beta naught plus beta 1 x. Okay. So these things, beta naught and beta 1, is basically what? Parameters. Parameters. So parameters will be evaluated. Okay, parameters will be evaluated while training. Okay, so when training is going on, so the optimal value of the parameters optimal value of the parameters will be founded while the training. Like you are minimizing the cost function, you are taking the other ways that how to minimize the cost function, and then you are getting your optimal value of the parameters. So while training, the whatever the values you are getting of the parameters, those will be called the parameters in that. But hyperparameters, these are the such type of the parameters where you have to provide the values. Like you have to decide that what will be the number of the neighbors when we are talking about the k nearest neighbor classifier. Okay, when we're talking about k folds, so you have to decide how many split you need. Okay, so that number of the k will be your the hyperparameter. How many what will be the other things. So this way we will check that what are all the things will be. Okay. So you go for this and let's move. So when we are going to take all these things again, we are taking the Daima, Indians, diabetes data set, all these things, X and Y we have taken. So let's just do and one hyperparameter tuning when we are taking K nearest neighbor. Okay. So K neighbors, this parameter, that is number of the neighbors that you are taking, whatever 10, 5, 4, that will be your uh, uh, hyperparameter. Basically, you have to decide that, decided by the uh, who is training the engineer, or who is training the data, model. Okay. So externally, you have to provide the value of the hyperparameter, and whatever the parameters that are trained while the training, that will be called the parameters. So, okay, so just you can take the grid search CV, grid search cross validation, that is very important, and from the model selection, this is again a model selection is there. Okay, so you can find here, uh, yeah. So K nearest neighbor, we have already gone these neighbors, K neighbors classifier and all these things. We have done all these things basically. Okay. So cross validation, we are taking 3 and KNN. Okay, KNN you are taking, and then just check that all these things. What will be the so this grid search, you are going to provide a grid, means the space of the number of the neighbors. So from 1 to 50, 1 to 50, this grid search, it will search for the, it will take basically 1, 2, 3, 4 up to 50, one by one. Number of the neighbors it will train the model, it will find the accuracy. And now the next number of the models, the number of the neighbors, it will take 2 and it will train, and then again it will find the accuracy. Then it will take a number of the neighbors 3, then 4, then 5, and up to 50. It will take all these things, and then finally it will find that what is the number of the neighbors that is optimal, that is giving best accuracy. Okay, so you can go. So hyperparameter tuning is what? That you have to decide that what I should provide the number of the neighbors. Okay, but you don't know that whether the number one, that neighbors you taken one, neighbors you take two, how many neighbors you take for this KNN. Okay, so you are providing 1, 2, 3, 4, 5. So manually, if you want to manually do, so you have to do manually these things, like you have to take one number of the neighbors one, then number of two, and train, and then find the accuracy, and then decide which number of the neighbors is giving the best accuracy. But instead of doing the manually, you can use grid search CV from the sklearn model selection. Okay, so it will do same thing, but in one line you can write all these things, and now you can check here. So it will give you the best score. The best score is basically 75%. And where you are getting best score, when the number of neighbors is 8. When numbers of the neighbor is 8, so you are getting the best score. So instead of manually putting like 1, 2, 3 and guessing that what will be the number of the neighbors, you can use grid search, and this will give you the optimal, the best number of the neighbors. Okay, so when you are going to do this, let's say when you are using decision tree. Okay, so in decision tree, you can go for the decision tree. Then it has many hyperparameter. Okay, decision tree. The decision tree only is still learned. Okay, so decision tree classifier. If you go, so you'll take that what will be the criteria and what is the max web depth, means how many labels you are going to split your data points, and you are creating the basically creating the tree. Okay, and what will be the minimum samples split. So minimum sample, if it is 2, then you at least there should be minimum sample to split the data set. So all these things, minimum sample leaf, that is one, and this minimum weight fraction, all these things are the basically hyperparameters that you have to provide while training. Okay, so these things you can find using hyperparameter tuning, and you can use grid search CV. So grid search CV is very important when you are going to hyper tune hyperparameter. Tune means what? Basically, tune means you are trying to find the best. Okay, you are trying to find the best value of the hyperparameter. Okay, so manually you can go for all the combination and permutation. You can do all the permutation and combination and permutations. But if see here, 1, 2, 3, 4, 5, you have to make like 50 times, 30 times, 40 times, train the model. Okay, but that is not a good way. So for that thing, you can use grid class, grid search CV class, and you have to provide the parameters for the criteria. You are going to decide whether Gini is good or the entropy is good. You have checked that while doing the decision tree, the Gini coefficient and entropy is these two criterion we are using. Okay. Max depth, you can check that what will be the max depth. Okay, 0, 5, 1, 2, 3. So you can provide as a list. Okay, and minimum sample also you need 2, 5, 6. So you are giving the possibilities, and you are checking that which possibility is best. So this grid search will decide that which one the combination is good one. Okay, so minimum sample leaf is left, all these things. So this is where I already have seen that decision tree classifier, how you are going to take. So from the scalar dot tree, you are going to import a decision tree classifier. Okay, this is the class. You are going to create a model that is basically object in Python, and you are taken a grid search. You are providing that estimator. Estimator is basically what? This is model, and then you are providing the parameters. So the list of the grid of the parameters. Okay, and this is you are giving the how many folds. Okay, this cross validation. Now you are this when you are giving this, now this grid search is basically trained on your data set. Now it will train respective data, respective, it will take Gini. Let's say it's a Gini as criteria. It's take depth none, it's take minimum sample split 2, it will take minimum sample leaf as 1, and it will train one model. Then it will take next like Gini and 5 and 2 and 1. So it will train again. So it will go and train all the combinations, and it will try to find out what is the best parameters. Okay. So trying to find out the best hyperparameter, it will give you like criteria. Gini is the best one. Okay. And then you find max depth is 5. Okay. This is, and it says that minimum sample leaf is 3 and minimum sample split is 10. So minimum sample split is 10, minimum leaf is 3. Okay. So instead of doing manually all the combination, you can use this very important library, sklearn library, scikit-learn, and you can use grid search, CV class. Okay. and accuracy on the basis of the best accuracy for these combinations. When criteria is Gini max depth is 5 and min sample is 3 and min sample split is 10. So the accuracy is 82.9%. This is the best accuracy and the combination of the best parameters. Okay. So, and if you're not providing all these things, so these will be taken by the these will be taken by the uh, like decision tree. You can go some default values are given. Okay, here criteria is Gini is given, splitter best, none, split is 2. All these basics like default parameters are given, but you have to decide that what is good, which parameter is good, what is the value of the parameters are good. Okay, for your data set. So on what combinations you are going to find out best. Um, yeah. So when you have decided that these are the best, so finally you again you train using these like criteria is Gini and all these things. Okay, these parameters, these parameter values. Again you train the model and save those that model for the future. Okay. So see here. So what we have done when you decided that your the best parameter, the value of the best parameters are like criteria is Gini, depth is 5 and these things. So now you use these parameters and you train again for the final training. Finally, you train your model and you save your model for the production. Okay. So we will stop here. We will use this. Okay, just you can run this. You can use Pickle. Pickle is an important library that you can use this Pickle to say model parameters value. Basically, model values, model weights value. Yes, if anyone is talking, so as Pickle, and you can again load the model and this model you can use. So basically when you get the model, so model is nothing but values of the parameters, okay, values of the weights. So those values of the weights you can use as .pkl file. Okay, so in .pkl file you can store the weights or the parameter values and yes, when you are going to in the production, so we will use. So in the next class, in the next sessions, we will see that after training the model, how we are going to save our model parameters basically. So we are taken model, we save the model. Now we are going to use the model and for your prediction for the new. Okay. So we will use our trained model, saved model. Now, when you get the saved model, now you don't need your data set, you don't need the training and all these things. Just this file is important. .pkl file. .pkl file you have weights, you have the values of the parameter. Now, whenever you are going to call your model, basically, so you can use that model, model values, this model parameter values, and you can predict for the new data points. So for the next two sessions, let's try to implement our full-fledged project using all these things. Okay. So we'll decide that most probably we are going to implement a classification model, and in that classification model we will try to implement using front end. Let's simple way HTML file will create, and in the back end most probably that we are going to use that Flask model Python Flask library, not library but is a framework basically, Flask framework, and we will see that how this model how we are going to predict our value and how can we display on the front end. So please let me know if you have any doubt at the end that we are about to conclude our session. It's the end of the time, end of the session. So next session will be on Monday, and next to next session will be on Tuesday. So in those 2 days, we will revisit all the things and we will build our model. We will and deploy our model. Okay. So development, the actual development, how it will look that in real life, that how you are going to implement your model, a machine learning model. These are the things that are required, how you are going to do pre-processing, how you are going to clean your data set, how you are going to build your model. So let's say if you are building your classification model, and so not only go for the decision tree or random forest, you build at 5, 6 models, okay, and you try to find out best model out of them, okay. So you get the best model, and out of the best model, you are going to deploy that best model, okay. So we'll see all these things. So hope that will be interesting. Like up to this is the machine learning part, and now the deployment, the model deployment will be good one. So that will be a complete project. So let's conclude here. So I hope. So Amar sir,
Oh, yes, sir.
so we can conclude here the meeting. Yeah.
Okay,
This
yeah,
session.
sure, sir. Thank you so much. So,
Thank
dear
you.
students, I believe that everybody mark the attendance. If not, I'm sharing that once again in the chat box. So please mark that, and we'll see you on Monday. So today is day 13. So we have 2 more days left. So in that, as sir mentioned, we'll cover the remaining things, and on last day we'll have a small MCQ test as well. Yeah, okay, guys. So thank you so much, all of you, for joining the day 13, and we'll see you on Monday. Till the time, enjoy your weekend. Keep practicing as well. Take care of yourself and take care of your family. Bye bye.
Yes.
Yeah, thank you.
You're welcome.